Okay, hello everyone. So today we're just going to go through a quick example on how you can make animations in Python. And so this can be used for plotting data that varies as a function of time. So maybe you have, for example, a series of images that varies as a function of time. And instead of having to look at different images at different points in time, you want to make an animation of it or a video of it. It can also be useful for plotting functions that vary with time. So that way, instead of having to plot snapshots of the functions at different points in time, you can make a video. And oftentimes this is really nice for presentations and things like that. And so the example that we're going to use, making an animation is also one of the bonus problems on homework 2, hence why we're making the supplementary video. And so the example we're going to use is the temperature profile that we were given in homework 1, problem 1, where we were given this temperature profile here. And this told us how the temperature varied in a system that was one-dimensional, where the left boundary had some temperature TL, the right boundary had some temperature T naught, and essentially wanted to know how the temperature varied spatially and temporally in this one-dimensional system. After class today, hopefully you all know that this solution is actually an FFT solution. It should look pretty similar. We have this series solution that has our basis functions here, and also the time dependence on in the exponential term. And so on the homework, what we ended up plotting was a non-dimensional form of this equation where we plotted theta, where theta was defined as this term over here on the left, versus x tilde and tau, where x tilde and tau are non-dimensional space and time. And so what we ended up doing on the homework was we plotted this function versus x for different taus. Sorry, x tilde and tau. And what you ended up getting was something that looked like this. I think the problem technically only asked to plot for tau is equal to 0, where you see that theta at the left boundary at tau is equal to 0 is 1, and everywhere else it's 0. However, what you can end up seeing is that as you increase time, the solution approaches a steady state solution. And so what we're going to try and do today is figure out how we could go ahead and make a video out of this instead of having this plot that has the plot as a function of tau. What if instead we just showed each of these curves at different taus in a video format? So kind of at each frame in the video, we have a different tau. And so we see how this temperature profile evolves in time through the video. And so to do this, we're going to use the matplotlib func animation function. And so the general process for how you use this func animation function is first we have to set up the calculation required for a function. So we actually have to just set up a function that calculates this theta sort of as a function of x and also for different times that we're interested in. After we set up that function, then we have to create an animation function that is a function of I. This I tells us what frame number we're at. And so that tells us at what time step are we plotting this function. And then after that, we make a figure, we use the func, we call the func animation function, and then we save the animation as either a video or a GIF. Um, it's much easier to see how this looks in actual code. Let's go ahead and go to that. Let me make sure my screen is being shared. Cool. So kind of we'll go through all of the steps for this. So first, the packages that we need to import are NumPy, we need to import matplotlib, and we also need to import the func animation function from the matplotlib animation library. One of the first things I recommend doing is running this command called plt.ioff. And essentially all this does if you're using a IDE is that it doesn't have the matplotlib window pop up. And this is really useful for animations because I've sometimes found that my computer can freeze. So then the next step is to calculate theta as a function of x and tau. In this case, x is going to be an array of x values that goes from 0 to 1. Tau is going to be the specific time that we want to evaluate theta as a function of x for. This should be something that you can copy and paste from the code you had to write for the first homework. The next important step is to create our animation function. So I called it animate. And so essentially what this does is it takes in a frame number. This frame number tells us what time we're evaluating it at. It also takes in our um, time array that we're going to create, which tells us how long in time we want to create this animation for, and then also x, which is our spatial variable. And so inside this animation function, what we need to do is first clear our plot. So that way we remove the previous data every time we create this animation. Then we need to get the axes for our plot, which is what this plt.gca command does. We then calculate theta as a function of x for our specific time. So you'll notice that here we're calling the specific time for the frame number that we want to plot. We then plot theta versus x. I also have some commands here that set the limits on the x and y axes, title the x and y axes, um, and then also tells us what time we are in the animation, which will be useful before. I also have this print I command, so that way I can kind of keep track of the animation as it's being created in case something goes wrong. So now that we've created our two functions, one for calculating theta, the other our animation function, then what we have to do is we have to create all of the times that we want to evaluate theta at. In this case, theta is being evaluated from 0 to 0.5, and we have 201 points in between that. The reason that we chose 0.5 is that if I go to this previous one, we can see that by tau equals 0.5, that we've reached a linear steady state temperature profile. And so now if we go back to our code, kind of the next steps that you have to do is you have to create a figure. So this can be done using the plt.figure command. You then have to add axes to that figure. And then the important bit is you call this func animation function. Remember that we've imported this function at the top. And to this func animation function, you have to give it the figure that you're animating onto. You have to give it the animation function. Here, because we didn't just specify the frame number as an argument for the animation function, we also have to pass our time array and our x array as arguments. We then have to tell it how many frames there are in the animation. In this case, the number of frames corresponds to the length of our time array. And then you also have to do this BLIT equals false. I haven't been able to get this command to work. Apparently, it can sometimes speed up the animation process. But after this runs, you've created the animation, and then you have to save the animation. And you do this using the anim.save command. And here we're going to save it as a GIF. And so if we go ahead and run this, you can see that it's printing out the frame number on the bottom because I have it set to print the frame number. This is just so that way it keeps track. This is going to go up to 200. Remember, indexing starts at 0, so it's going to go from 0 to 200. After it gets there, it will pause a second because now it's saving our animation as a GIF. And then now if I go over on the left and open up this GIF, we can see that we have a plot of the temperature profile versus X for different times. And so we can watch it play. What you'll see is that eventually we start to reach this kind of steady state linear temperature profile. And so now by around time equal to 0.3, we have this linear concentration profile. Please also note that the time unit should be dimensionless here. I used the same code that I did for the problem on homework 2, so I didn't change that now. But great. Hopefully that helps you all make your animation for the homework problem on homework 2. And if anyone has questions, please feel free to ask.